All right. I am recording now. So uh, the instructions for lab 5 start with, in this lab, you're using the physics. Sorry, they give you the link, the procedure. So go to the above listed URL. So let me do that. Let me share my screen with you. Okay. And click on the center of the rectangular box. Okay. So we have the variables mass of the Wally, the astronaut, the magnitude of the propulsion force from the fire extinguisher, and the duration of propulsion force from the fire extinguisher. Okay. And then you see the variables here at the bottom. Okay, Wally's mass that you can change, you can increase it or decrease it. And then the force from the fire extinguisher, you can increase it or decrease it. It's set at 85 Newton now. Okay, and Wally's mass is 82 kilograms. So we need to click begin. Okay. Okay. So what do you think? So we have an astronaut up there. And then he's gonna push on the button on his fire extinguisher. And what do you think is gonna happen? Somebody. So the person is in space. His name is Wally. Right here, he's holding a red fire extinguisher in his hand. When he pushes the button to fire the fire extinguisher, what do you think is gonna happen? Once he starts spraying. Any idea? No? Well, let's do that. Let's activate. Let's push the button. So he sprays and starts moving. Shuts off. Okay. See what happens? The spray goes to the right and he moves to the left. How would you explain that? Anybody has any idea? How you could explain this? Let's say using Newton's 3 laws of motion. Or is any of the 3 laws relevant for this problem? What are Newton's 3 laws of motion?
Is this an example of like the action reaction force?
Yes, that's what this is. Yes, absolutely. That's the 3rd law. Yeah, action reaction. Of course. Okay. So that's correct. That's absolutely correct. So the spray goes to the right and he moves to the left. Action reaction. Okay. Now, so then you have to answer the questions on the first page. Where is the fire extinguisher propulsion effort doing to all his body mass per second in spraying? Then how would you calculate the speed? And which of the 3 laws, Newton's 3 laws, are applicable? Okay, we have a newcomer. Now, the second page has most of the instructions. And what you are told to do is, so you have three variables: the mass of the astronaut, the propulsion force from the fire extinguisher, and the duration of propulsion force from the fire extinguisher. So that's time delta T. Okay, so F will designate the force, the propulsion force from the fire extinguisher as F net, the mass of the astronaut as M sub W, and the time that that force acts on the astronaut as delta T. Okay. So what you're going to do is hold two of these three variables constant and change only one of them. Okay, so let me explain. So you're going to set up three tables, okay? And therefore you will end up with three graphs, okay? And each time from these three variables, you will hold two of them and you will change only the third, okay? In the first case, so the first table, okay, we want to keep, so in order to plot, okay, so basically we are studying the variation of F net, the force, the net force, times the time delta T, that net force is acting on the astronaut. Okay, what's this quantity called? Force times the time elapsed. Okay, that's the impulse, right? That's the impulse. Okay. Which is equal to the change in momentum. Now, we want to study the relationship that exists between that variable, so F net times delta T, so that's the impulse, and the speed of Wally. Okay. Now, using what you know from physics, you should be able to find the speed, right? You can use Newton's second law, for example, and then you can find the speed, Wally's speed, okay? In order to do that, you will have to hold delta T, so out of those three variables, the variables that I mentioned on the second page, so the mass, the force, and delta T. For the first table, you will have to hold delta T and the mass constant. And the only thing you'll do is change the force. And each time the force changes, you will have to calculate the speed and associate a speed to that value of the force, so that you can set up your table and eventually graph the results, so your data points, okay? You need, I think, 5 data points each time. Yes, 5 trials, okay? So you will change the force. So each trial will have a different force, and you know how to change the force here with the green arrows here, extinguisher force. Okay. I'll have to click reset. You see, when I click, the force changes up or down, okay? And the time, of course, the time that you want to keep it constant, so you will have to stop. So if you decide that the time 20 milliseconds is 2000 milliseconds, click activate, and oh, sorry about this. So I click activate, and okay, reset. Yeah, so that's about 1800. Okay, read again. Okay, So you have to practice a little bit, okay, so that you keep the time about the same. Okay, this 1800 and 2000, there's a difference. So let me try again to get to 1800. Okay. Oh, no, no. Try again. Too soon. You'll have to practice. And this is good enough. 1900, 1800. Let me try again. Right, that's correct. Again. Yeah, that's fine. That's good enough. Okay. So practice a few times, and then you get used to it. So for the first case, you will keep delta T constant, you will keep the mass constant, and you will change only the force. And for each trial, there will be a different value of the force, and therefore a different value of the speed. Okay, speed is the final speed. Okay, and you can calculate that using Newton's second law, for example, or using change in momentum equals the impulse. Okay, so or other formulas that you learned in class. For the second table, so part 2, and therefore the second graph, we want you to plot the force against the speed, against Wally's speed. So in this case, once more, you will keep delta T constant and Wally's mass constant, and you will change only the force. Okay, net force. And for the third case, we want you to study the variation of Wally's mass against his speed. So in this case, you will keep the force constant and delta T constant, and the only thing you will change is the mass. Okay. Yeah. But as the mass changes, the speed will change also. Okay. And you can see this easily using formulas. Okay. Maybe let me go to the whiteboard so that I can show you. Maybe Word, Microsoft Word. So Newton's second law is I'm gonna do it. Force equals what? Mass times acceleration, right? Okay, in one dimension. Okay, so so now acceleration is mass is the change in velocity by the change in time. Okay. Now you can solve for the mass. That's pretty easy. So you get force okay, I forgot to divide by V. equals the mass. Okay, so let me rewrite it. So mass equals the impulse, which is force, times the amount of time this force is acting, times the reciprocal of the change in the velocity. Okay, so you see that with this equation now, we have been able to express the mass as a function of the change in velocity. But this is the change in velocity is the same as just v final, because the initial velocity was 0. Okay, so this is the same as v or v final. Okay, so if you keep f and delta t constant, and as m changes, delta v changes. Okay. All right, and then you will have to make a graph of that. Okay, so you will need 5 different values of the mass. Okay, so 5 different astronauts if you want. Okay. And then see how the mass changes as a function of the velocity when the force and delta t are held constant. Now, let me go back to the simulation. Okay, reset. So Wally's mass is 70 kilograms. Okay. Now, the force on the fire extinguisher is 100 Newton. So that's the force with which the fire extinguisher is pushing him to the left. So click on activate. Okay, it pushes him, and releases the button, and it stops pushing him. Okay, and the momentum that he has at that time is 702. Okay, I can change the force, decrease it, for example. I'll have to reset first. 50. Let's see how much. So it still pushes him, not as hard as before. It's off, and he keeps moving, of course. Okay. After how much time is he going to stop moving? Any idea? Or how would you calculate that? No idea? Okay. And then you can change his mass. Okay. So increase it. I mean, in this case, it wouldn't be his mass that you're increasing. That would definitely be a different astronaut, because somebody's mass can't just change from 70 kilograms to 90 kilograms. Okay, so that's a different astronaut now. Activate. Okay. And it's harder to push him now, right? So he's moving in space. Okay, there's no more force on him from the fire extinguisher. And what's going to happen to him? When is he going to stop? No idea? Okay. So I think I showed you everything. I showed you how to change the force. I showed you how to change the mass. And I showed you how to take care of delta t. Click activate, and then you stop. Okay. And you can set your own delta t. Are there any questions before you start? All right, so then it's your turn. You can start working on the lab.